Greetings to all. In this video lecture, let's see the basics in information theory and discrete memory-less source. Okay. So, what is communication? Basically, communication is transfer of information, right? So, if, for example, if you want to transmit any information from one source to another, okay, we perform communication, right? We perform communication. So the performance of this communication system is determined by the probability of error. So, for example, I want to transmit, imagine a text, okay, from the source to the destination. Okay. So whatever content that I send, okay, for example, let me say, hello, how are you? Okay, this is the text that I am sending from the source. The same information should reach the destination, right, without any error. So I say my communication is effective, or the performance of my communication is effective if I could receive the same text. That is, when I say that is, the probability of error should be 0. So unless and until the probability of error is minimum, we can say there is no error during transmission, and my communication is stable. Okay. So the performance of the communication system, it's highly measured by the probability of error, or the error probability. So again, the performance system also depends upon the signal power, the channel noise, and also the bandwidth. Now, what is information theory? Okay, so it's basically information theory is used for the mathematical modeling and analysis of the communication systems. Another definition is, as we read here, information theory is a mathematical approach concerned with the content, transmission, storage, and retrieval of information used in the form of message or data, especially by means of computer. So it is a mathematical approach how which data is stored and how which data is transmitted and retrieved. Okay. So this the mathematical approach that we give to is nothing but information theory. Okay. Then we'll just discuss about what is discrete message. So first let me read a definition. The information source is said to be discrete if it emits only one symbol from the finite number of symbols or message. For example, imagine I'm testing my friend, okay, saying hi, okay, hi, okay. So hi, it is basically if I am testing somebody, hi, okay, it's two alphabets, one is H, one is I, right? So I call it to be discrete message if, okay, there is only one code word or symbol, if there is only one code for H, and if there is only one code for I. Okay, so if there is only one symbol that exists or only one code word that exists, we call that to be a discrete message. So let's say consider x, okay, equal to x0, x1, x2 up to x of k minus n, symbols having probabilities p1, p2, etc. up to pk minus 1, okay, which can be written as probability of x belong to xk is equal to pk. Okay, so here k tends to 0 to k minus 1. So the sum of probability are the set of the sum of probabilities should satisfy the summation k equal to 0 to k minus n. Summation pk should be equal to 1. For example, so if there are only two symbols, okay, for example hi, okay, hi is two symbols. So if you add, if there are only two symbols that exist, okay, in a message source, okay, the probability of H and probability of I should be equal to 1. Sum of probability of all the symbols, okay, should be equal to 1. We'll see what is a discrete memory-less source. Okay, so what is memory-less? We saw what is discrete. We'll see what is memory-less. Okay, we call anything to be memory-less, okay, if the output depends only upon the current input. Okay, so any symbol you take, for any alphabets, okay, any alphabets, we try to generate a code word. So these code word which is the output is not depending upon any of the input. So that is why we call as memoryless. Again, I'll read out the full definition. Discrete memoryless source. So when the current output depends only on its current input and not on any of the previous symbols, then the discrete source is said to be memoryless, or is called as discrete memoryless source. So the code word that we generate does not depends on any other input, or so it is totally independent. So the current output depends only upon the current input. That's why we call that system to be a discrete memoryless source. Okay. Now we shall discuss about the amount of information. So let's consider a communication system. Okay, transmits M1, M2, M3, etc. up to MK message with probabilities P1, P2, P3, etc. to Pk. So the amount of information transmitted, okay, K is given by log 1 by Pk. R is equal to minus log Pk to the base 2. Okay, so since this Pk goes up, okay, we try to add minus. Okay, so here the definition says the amount of information received from the message is directly related to the uncertainty or inversely related to the probability of occurrence. So now what is uncertain? We say it inversely related because we have 1 by Pk. Basically, what is uncertainty? So imagine if we know an event is likely to happen. Okay, so any probability, the probability lies between 0 to 1. So if we know the event will happen for sure, okay, we say, and if you see the probability is to be 1, like if you are very sure the event is supposed to happen, okay, we can say the probability of the event is supposed to be 1. So uncertainty means we may not know it may happen or not. It's a very rare chance of occurrence. That way we say uncertain. So in uncertainty, like the probability of error will be very much minimum as much as possible. Okay, so that is we call that to be an uncertainty. So let's see the properties. We'll understand more about this amount of information. So the first property is, if there is more uncertainty about the message, the information carried is also more. So if there is more uncertainty about the message, the information carried is also more. So as I told you, when I see if some event is occurs very rarely. So let's say that today is Monday. Okay. So I'm saying tomorrow is Tuesday. So if today is Monday, tomorrow is going to be Tuesday for sure. So that is the probability of occurrence of the event is certainly known. We say the probability is 1. Okay, let's not change it. For example, let me say tomorrow there is a probability rain may come. Okay, or tomorrow, surprisingly, I'm saying this minister is some politician is going to come to my home. This is a very rare occurrence, very uncertain, very rare in occurrence. So in such case we say, okay, the situation is more uncertain, or the probability is more uncertain. So that's why here says, if there is more uncertainty, that is lower the probability, higher is the information content. So if the probability is higher, the probability of occurrence is higher, the amount of information is lower. Let's say if the probability is 0, okay, let's say for the uncertain message the probability is 0. Definitely, and if I substitute Pk equal to 0 in the formula for information, so Ik equal to log to the base to 1 by Pk, and if I substitute Pk equal to 0, I'll get 1. That's why I say if the probability is 0, the amount of information is more. Okay, so lower the probability, higher the information, higher the probability, lower the information. Okay, let's go to the second property. That is the second property. If the receiver knows the message being transmitted, the amount of information is 0. That's why I told you, if we know what is going to be transmitted, okay, If I know like okay, this is what is going to be transmitted. If the receiver knows what is going to be transmitted, I'm very sure the probability is going to be 1. So if I substitute the value pk equal to 1 in the information ik, okay, so ik equal to log 1 by pk, where log 1 by 1, so it's log 1, which is 0. So it is actually vice versa, right? That's why I told you, if the probability of information is known, then the amount of information carried is 0. That is your second property. Let's go to the third property. The third property is, if I1 is the amount of information carried by the message M1 and I2 is the amount of information carried by the message M2, then the amount of information carried by M1 and M2 is given by I1 plus I2. So if I1 is, so it is self-explanatory. If I1 is the amount of information in M1 and I2 is the amount of information in M2, then the amount of information carried by both M1 and M2 is nothing but I1 plus I2. So I of M1 and M2 is equal to I of M1 plus I of M2 is nothing but log to the base to 1 by P1 plus log to the base to 1 by P2. Okay, this is self-understood. The fourth property is, let me read, if there are M equal to 2 power equally likely messages, then the amount of information carried by the message will be n bits. All the messages are equally likely and independent. Probability of occurrence pk equal to 1 by m. Okay, how to explain this? Imagine that we have 4 symbols. Okay, we have 4 symbols. Let's take x1, x2, x3 and x4. So value of m is equal to 4. Okay, so in case m is equal to 4, what will be the value of n? M equal to 2 power n. So 4 equal to 2 power 2. So the value of n is equal to 2. So here the point is, if you have 4 symbols and the probability is same for all the 4 symbols, imagine like the sum of probability is equal to 1. And let me say the probability, if all the 4 are having same probability, so each one is supposed to have probability of 0.25, because 0.25 plus 0.25 plus 0.25 plus 0.254, right? Probability of occurrence of x1 is 0.25, probability of occurrence of x2 is 0.25, probability of occurrence of x3 is 0.25, and probability of occurrence of x4 is 0.25. Okay, if the probability is likely to be same, okay, so the amount of information is supposed to have only n bits. Okay, that is 2 bits. That is the amount of information. Okay, ik equal to log 2 to the base 1 by pk. Okay, so this is all about some basics about what is information theory, amount of information and their properties. Okay, so if you want, let me just go back and revise it once again. So what you have seen so far is what is information theory. And information theory is nothing but a mathematical approach concerned with the storage, transmission and retrieval of information, okay, from the computer. And again we saw what is discrete message. So we call something to be a discrete message if it has a finite symbol or a finite code. Okay, we call something to be a discrete message if there exists only one symbol for the finite number of messages. Okay, so again, what is a memoryless system? If the output depends only on the current input, then we call it to be a memoryless system. Okay, and then again the amount of information formula is ik equal to log 1 by pk. So the property 1 is, if for an uncertain event we say the probability equal to 0, therefore the information is higher. And for the known event, okay, if the receiver know what is being transmitted, the probability is equal to 1, again therefore the information transmitted is 0. The sum of information I of m1 comma m2 is equal to the individual information I of m1 plus I of m2. The fourth probability is, if m is equal to 2 power n and all the probability are supposed to have, all the messages are supposed to have same probability, then it's going to have n bits. Okay, thank you for watching this video.